Hi, good evening, everyone. The class will begin shortly. If you can see my screen, please indicate so in the chat. Thank you. Okay, I'm only seeing one person watching, so that has to be me. Okay, Janelle, Levana. Okay, good night. I was worried that it would be just me tonight. All right. This evening, I want to indicate to you all that I found out that there are some additional exams that I was not really paying attention to. Tomorrow is English B and Monday is POA. All right, Tuesday is English, Wednesday is maths. I didn't realize that all these exams clustered together. So what I'm gonna do here, I'm just gonna do 3 measurement questions tonight. Saturday night I will do algebra and I'll just do some number theory for 7 on Sunday instead of doing a whole day class because I didn't realize all these exams crop up on us this quickly. And I want to give you time to be able to focus on your other exams as well. I will still meet with you all on Tuesday for 7, just for about 10 minutes. But tonight we'll be doing 3 questions. We'll do January 2017 to January 2016. I understand, Janelle, but it wouldn't make sense to put all this amount of work Sunday, given that it has too many exams close by. I want the students to be able to focus on their exams. These past papers, while they are for practice and so on, it's to help the students, and that's why I leave these easier questions coming closer to the exam, because I really don't want to panic anybody, okay? But you have ample questions that you can revise from work that we did before, okay? Hi, good evening, Vanessa. All right, so I just want to share with you a motivational thought. I know I had a nice chicken joke last night, scratching like a chicken. And I told a child that the only place he knew about chicken was KFC. So I um I have a thought for you from Colonel Sanders. It says once there was an older man who was broke, living in a tiny house, and owned a beat-up car. He was living off $99 Social Security checks. At 65 years of age, he decided things had to change, so he thought about what he had to offer. His friends raved about his chicken recipe. He decided that this was his best shot at making a change. He left Kentucky and traveled to different states to try to sell his recipe. He told restaurant owners that he had a mouth-watering chicken recipe. He offered the recipe to them for free, just asking for a small percentage on the item sold. Sounds like a good deal, right? Unfortunately, not to most of the restaurants. He heard over 1,000. He heard no's over 1,000 times. Even after all those rejections, he didn't give up. He believed his chicken recipe was something special. He got rejected 1,009 times before he heard his first yes. With that one success, Colonel Sanders changed the way Americans eat chicken. Kentucky Fried Chicken, popularly known as KFC, was born. Remember, never give up. Always believe in yourself in spite of rejection. Okay, so let's hope that CXC don't reject any of you all and give all your bad grades below a 3. Yeah? But work hard and let's get some work done. All right. Good evening, everyone who just joined us. All right. Um, so let's get down to this. All right. So let me get my tool here. All right. So we're gonna start off here with January 2017. Okay. This is paper 2, question 6. Part A. The scale on a map is 1 to 25,000. Now I want you to notice this here. This 1 to 25,000. Anytime you see these scales here, this is in centimeters. 1 centimeter on the map represents 25,000 centimeters in real life. Okay, and you'll have to do the conversion. You'll always need to remember this, that 1 kilometer is equal to 100,000 centimeters. This is a conversion factor that you need to learn. Now you can see how I derive this. We know that 1,000 kilometers have 1,000 meters. All right, and we know that 1,000 meters multiplied, and each meter has a centimeter. So when each meter has a 100 centimeters. So 1,000 multiplied by 100. That's how we come up with the 100,000. Okay. So learn this, please. 1 kilometer is equal to 100,000 centimeters. So part 1. Andalusia and Jersey are 31.8 centimeters apart on the map. Determine in kilometers the actual distance between Andalusia and Jersey for 2 marks. Okay, so they want the distance here. They said the distance on the map here is 31.8 centimeters. All right, and they want the actual distance. So I'm going to write here 31.8 centimeters. And I have a scale here. All right, that 1 centimeter on the map represents here 25,000 centimeters in real life. Okay, and we know here that 100,000 centimeters is equal to 1 kilometer. That's the conversion factor that we're using here. Okay, so notice here that centimeters will cancel with centimeters, centimeters with centimeters. All right, so you remain with the distance in kilometers. So this is 31.8 multiplied by 25,000, and I'll just put the kilometers here, divided by 100,000. So when I do this here, I'm going to get a value here of 7.95 kilometers. Janelle, just check away you're working. You're just off by a decimal point somewhere. Okay? Something went up Barely up there. I'm not really sure what it is. All right, 7.95 kilometers. All right. Okay, so let me just go it over here. Make sure that everybody understand. This is the distance on the map, 31.8 centimeters. And they gave me a scale here, 1 centimeter is equal to 25,000 centimeters. And I know this conversion factor. I totally learned this. 1 kilometer is equal to 100,000 centimeters. So this, I'm just going to use this to convert the centimeters here to the centimeters here. This cancel the centimeters to convert to kilometers. So the centimeter cancel with centimeter, centimeter with centimeter, and I'm remaining with kilometers. So numerator by numerator and denominator by denominator. So this is 31.8 multiplied by 25,000 divided by 100,000. Working this out on the calculator here, I'll get 77.95 kilometers. Okay? All right, so part 2 now. They want here the actual distance between Clifton and the actual distance between Clifton and Jamestown is 2.75 kilometers. How many units apart are they on the map? So we're going backwards here now. Okay? So you're going to start here with 2.75 kilometers. All right? And we know here that 1 kilometer is equal to 100,000 centimeters. So all I did here was convert this kilometer to centimeters so far. Now, what I need to use here is the scale. Okay? They gave me here, all right? In this scale here, they gave me here that 1 centimeter on the map represents 25,000 centimeters in real life. So I'm going to write here this 25,000 centimeters here in real life would represent 1 centimeter on the map. Now, notice here, kilometers with kilometers, centimeters with centimeters. So I'm just remaining here with centimeters. Okay? I'm seeing 11, that's correct. So yes, Adrian, like you put it and retracted or something just now. All right, so this is 2.75 multiplied by 100,000 all over 25,000. And this here is centimeters. I'm getting here 11 centimeters. Okay, so I'll just run it through again. I start with the actual amount in kilometers here that they gave me, 2.75 kilometers. I use the conversion factor to convert kilometers to centimeters, but this is centimeters in real life. Now I need to use this scale here. I know here that 1 centimeter on the map is equal to 25,000 centimeters in real life. So kilometers with kilometers, centimeters with centimeters, and multiply numerator by numerator, denominator by denominator, and just divide this on your calculator and you get an 11. Okay? Do you all understand this new method that I taught you all in the workshop? All right. As I indicated to you, it's not really a technique that is taught in math like this. Okay, this is more of an engineering thing. But just let me know if you all understand the method I would have taught, okay? All right. Part B, the diagram below shows a square ABCD drawn inside a circle. The vertices, the vertices of the square lie on the circumference of the circle. The length of a side of the square is 11 centimeters. Okay, so part 1, show that the diameter of the circle is 11 root 2 centimeters to 2 marks. Ajay, no, this is we're in paper 2 here. This is January 2017. All right. This is January 2017, number 6. We're in 6B now. Okay? Janelle, I'm glad you understood the technique, okay? Alright, so they want you here to show the diameter. This is the diameter here, AC. Show that the diameter here is 11 root 2. So let's look at this diagram carefully. So they give you here that this is 11 square root of 2 centimeters. Okay? Alright. Now, you'll notice that very carefully. If you notice, you look carefully here. Do you see ABC? This is a triangle, and it's a right angle triangle. Now, remember that we can use SOHCAHTOA and Pythagoras theorem when we have right angle triangles. Now, but we need another angle here if to use SOHCAHTOA more than the right angle. So we definitely cannot use SOHCAHTOA. But you could use Pythagoras theorem. All you need to do is to establish that it is a right angle, and you just use the Pythagoras theorem, which states that the hypotenuse squared, which is the longest side of the triangle and is opposite the right angle, is equal to the sum of the squares of the other two sides. What that means is if I square AC, AC squared is equal to AB squared plus BC squared. So I'm going to use that relationship, as well as the fact that it told me the length of the side of the square here is 11 centimeters. So I'm going to write in those 11 values. Let me write here. 11 centimeters. All right. This is 11 as well. 11 centimeters. Okay? Okay? So, they ask us here to show that the AC, which is the diameter here, is 11 root 2. So, let's go and prove that there. So, I'm going to write here by Pythagoras theorem. All right, so this is AC squared is equal to AB squared plus BC squared. Hypotenuse squared is equal to the sum of the squares of the other two sides. Nicholas, this is not all right. Well, let me see my calculator here. Just now, I saw a custom with the surds. All right, so that's how you all got the 15.5. 11 root 2 is 15.5. Okay. When they say show, they mean here that they give you 11 root 2, which is the answer. They want you to show how you come up with it, okay? They know the answer is that 15.55 or 11 root 2, okay? So, I'll write here that AC squared is equal to 11 squared plus 11 squared. So, AC squared is equal to 121 plus 121. So AC squared is equal to, this is the square root of, AC is equal to 242. So AC is equal to the square root of 242. Now notice here that I could express this as AC is equal to the square root of 121 multiplied by 2. The square root here, 242 here is the same as 121 by 2. Okay? And I could break this up here. AC is equal to the square root of 121 multiplied by the square root of 2. AC here, square root of 121 is 11, and this is root 2. Okay, and if you want, you could put your QED. All right. Now, this actually tests your ability to understand how surds operate a little bit um, from AdMaths. But I'll go and try to break it down as best as I could, okay? So, by Pythagoras' theorem here, AC squared is equal to AB squared plus BC squared. So, AC squared is, we know AB and BC is 11. So 11 squared plus 11 squared, this is 121 plus 121 is 242. To remove this square here, I have to take the square root on both sides. So I get here the square root of 242. Now, I could break down the term here inside 242 inside the brackets, inside the square root, and express it as 242 is the same as 121 multiplied by 2. I'm doing this specifically so that I could easily find the square root of 121. This is something, like I said, well, at least I would teach the students in AdMaths to do sometimes because you want to express something in this when you're teaching surds. Okay? So you could break this here apart. When you have the square root of 121 by the square root of multiplied by 2 here, you could break it apart and say square root of 121 multiplied by square root of 2. Square root of 121 here is 11. So this is 11 multiplied by root 2. Okay? So that was the 2 marks. All right. Part 2. Write your answer correct to 2 decimal places. Calculate the area of the circle. All right, for 2 marks here. So we know here that the diameter of the circle, all right, they show that the diameter here is 11 root 2, which we showed here. So the diameter is 11 root 2. Okay? Now, there are 2 formulae for area, which is basically the same thing. All right, area of a circle is pi r squared. You could use calculate the radius here by dividing by 2, or you could say area here is pi d squared over 4. Okay? Pi multiplied by the diameter squared all over 4. All right, d here is the diameter. It's the same thing. Okay? It's the same thing. Just different ways of expressing it. I'm going to choose to use the right hand side one, but you can use this one as well, okay? So area here is pi d squared over 4. Area is equal to pi multiplied by the diameter squared. This is 11 root 2 squared all over 4. So when I multiply all this out, okay, I am able to get here on my calculator, I'm getting here 190.09. Maybe I should break down this a little bit for you. This is pi, 11 squared is 121. All right, and 121 multiplied here. When you square root, you remove the square, so this becomes 2. Okay, all over 4. Here is pi multiplied by, this is 242, all on 4. Okay, so when you work this out in the calculator, here you're going to get here 190.09 centimeters squared. Now, there are several ways you could work this. You could use the area is pi r squared as well. And even in the calculation, you could do different things. You could plug in everything in your calculator, or you could do like Nicholas, and if you don't understand surds and thing, you work with your what you have there with your 15.55. Okay? So work with what you have, okay? And what you understand. Is that clear? All right. Part 3. Calculate the area of the square. You'll find the area here for me, please. Leon, I hope the measurement comes easy as well. I want the weaker students to pass the math. All right, so there needs to be some easy questions on the paper. Okay? And I wish that every year. All right, you'll find the area of the square. Primary school work. All right, you have the side of a square here is 11. Yes, Vanessa, 121 cm squared. Area of a square is side by side. Area of a square is side by side. So 11 by 11 is 121. All right. Area is equal to side square, which is 11 squared, 121 cm squared. Excellent. All right. Part 4. Calculate the area of the shaded section. All right, so let's go to the diagram here. The shaded section is this region here. Now, in order to find the shaded section, what are you going to do? We have the area of the circle, which is 190.09. We have the area of the square, okay, which is 121 cm squared. All right. Take the area of the circle and subtract the area of the square. And notice that this shaded region is one of 4 equal parts. Okay? So when you subtract the area of the circle minus the area of the square, just divide it by 4 and you will get the area of the shaded region. So I'll set it up here and I want you to work it out. So area of the shaded region is equal to, this is 190.09 minus 121 divided by 4. All right, tell me answer there. 17.27 is correct. That's correct. Okay, so this here is the area of the circle. This is the area of the square, and you just divide by 4. All right, Nicholas, I'll go back to the diagram and show you why I divide by 4. Maybe I should write out the words and then here. So when you're revising, you will know, right? Area of circle, CIRCLE. Minus area of square. All right, and this is all divided by 4. So this is 190.09 minus 121 divided by 4. This here is equal to 17.27 centimeters squared. All right, so let's go back to the diagram here. Notice here they want you to find the area of the shaded region. This is the shaded region here. But the shaded region is one of 4 equal parts like this. Okay, remember it's a circle that it's a square inside of a circle. Okay? So seeing that the squares have equal sides, it means that this region here, this segment here will be equal. these segments of the circle will be equal. Okay, simply because the sides of the square are equal in length. Well, it's a square. So, okay, so that's why we divide it by 4, because there's only one shaded segment of the circle. Is that clear, Nicholas? All right, so that's the end of the first question there. All right, so this was January 2017. Let's go to May 2016. All right, good. May 2016, question 4. All right, Teresa, you should recognize this question from mock exam. Eh? All right, so May 2016, paper 2, question 4. The diagram below, not drawn to scale, shows a silver box with no lid. You all pay attention to this no lid story here. See, real children got this thing wrong because they weren't reading the question carefully. All right, so the diagram below, not drawn to scale, shows a silver box with no lid. The sides and the bottom of the box are 1.5 centimeters thick. Okay? Part A. Calculate the volume of the box using the external measurements. External. So it means that these lengths here, all right? So your length here is 30. Your breadth here is 20. And your height here is 15. So I want you all to go and find the volume here. Find the volume of this cuboid. All right, they said external measurements, so you use those lengths, that length, breadth, and height there. Tell me what you're coming up with. (9,000 cm cube is correct. Okay. So let's multiply here. We have 30 multiplied by 20 multiplied by 15. Okay. When we multiply them up, you're getting here 9,000 cm cube. Okay. That's pretty straightforward. Pretty straightforward. All right. Part B. Complete each of the following statements. Okay. The internal length of the box for 2 marks. Okay. The internal length. So they give you this 2 multiplied by 1.5 here. Let me go to the diagram and let me show you how they get in that. Remember the wall thickness here is 1.5, and the wall here, it have a wall here and it have a wall here. The only place it doesn't have a wall is the top of the box. All right, so the bottom of the box has a wall, the sides have walls, wall thickness to deal with, but the top of the box has no walls at all. Okay, so 27 is correct. 1.5 by 2 is 3. 30 minus 3 is 27. Easy 1 mark. Now they want the internal width of the box. Look carefully at the box here. All right, when they say width, they mean the breadth here. So go ahead and find the internal width is. And put your answer in the chat. Okay, 17 centimeters, because remember, they have walls on this side and walls on this side. Okay, so 1.5 multiplied by 2 is 3. 20 minus 3 is 17. So 17 centimeters is correct. Okay, so now find the internal depth of the box, which is the height here. So go find the height there. Think about what you're doing. 13.5 is correct. And it's 13.5. Remember what I said. It has a wall at the bottom, but it has no lid. It has no lid, so it has nothing on top here. Is that clear? There's no wall on top, so there is no thickness to subtract on top. So just the 15, this height here, or this depth here, 15, minus, well, the height, not depth. The height, 15, minus the 1.5 will give the depth. Okay? The depth is to the inside of the box. Okay? From the top to the inside of the bottom of the inside of the box. The height would be the external height here. So this here is 15 minus 1.5, and this is 13.5 centimeters. All right, so part C here, calculate the internal volume of the box for 2 marks. When they say internal volume, you're going to use the internal length, width, and depth to calculate the internal volume. You have all the values here on this page. Use them and calculate here for me the internal volume, please. Janelle, that's correct. All right. I just want the others to see what the values there. Copy it down and do it, please. Type it out on your calculator and work it out. Okay, so I'm gonna work it here now. So the internal volume, all right, will be 27 multiplied by 17 multiplied by 13.5. Okay, and remember this is centimeter by centimeter by centimeter, so you get in cm cube. Okay, so you will get here, oh boy, 6,196 196.5 cm cube. Okay. Which part was good? Tell me, and I'll go it over. You mean the calculation for part 3 here? Oh, the part with 2 by 1.5. All right, lovely. All right, so let's go to the diagram here for the internal length and the internal width. Notice here, Yes, I saw that we did multiply by 1.5 by 2. All right, so let's go as to y. This is the length here. You notice that there is a wall here and there's a wall here. Wherever there are walls right around the box, and there's a wall, well, there's a bottom on the box here. So that has a thickness here. It says it's 1.5 centimeters thick. So in terms of for the internal length, you have 1.5 here centimeters for wall and 1.5 centimeters for wall. Okay? So you have to account for the walls. All right? So in order to find like the internal length, think about this like a room. The blocks that you use to build the walls of the room, you need to account for their thickness. All right, to actually get here the the actual internal length. Okay, I hope that analogy um, could help you to visualize what's happening inside of this box here. Okay, so this is 30 multiplied by 1.5 by 2. All right, 1.5 by 2 is 3, 30 minus 3 is 27. In the same way, for the breadth or the width, you have a wall here, you have a wall here. So 1.5 multiplied by 2 is 3, 20 minus 3 is 17. All right, so that's how we come up with our values there. All right, part D. The box is made of silver, which has a mass of 10.5 grams for each cm cube. All right, this should have been cm cube. All right, calculate the mass of the silver box given your answer in kilograms. All right, for 3 marks. All right, so they want the mass of the silver box. All right, now what you need to do is to find the mass of the box. We need to find the mass of the box, yes, but we have to find the volume first of the box, because what happened is that they give you here the mass as 10 grams for every cm cube. This is actually density. A gram per cm cube is density. So they give you a density here of 10.5 grams per cm cube. So I need to find the volume of the box itself. Remember, we found the volume of the entire box and we found the volume, the internal volume. Okay, so if I say the volume of the entire box minus the internal volume, I'm going to get the volume of the box. So I'll start with that here. Volume of the box is equal to the external volume minus the internal volume. All right, now the external volume we found to be 9,000. Y'all remember that? So this is 9,000, and the internal volume here we found to be 6,196.5 cm cube. So when I subtract these, I'm going to get here 2,803.5 cm cube. So now, what I want to do here, I want to use this density they gave me here. So I have here, I start with the 28,2803.5 cm cube. And even if you didn't recognize this was density, like the name itself, you're just using it, all right? 10.5 grams per cm cube. So I know here that this is 10. This is the correct place. 10.5 grams. And when they say for each cm cube, it's per cm cube. So the cm cube coming down here. Okay? And I want you to notice this. Cm cube will cancel with cm cube. Now I know most of you, You would just take the 28.03.5 multiplied by the 10.5 and not even worry about how the units get to the grams. Okay? But we're not finished. They want it here in kilograms. So I need to add in a conversion factor. I know here that 1000 grams is 1 kilogram. Okay? So the grams will cancel with the grams and you remain with kilograms here. So just multiply all these values here. This is 2803.5 multiplied by 10.5 all over 1000 kilograms. Okay? And when I multiply this out to two decimal places, this will be 229.44 kilograms. All right, Nicholas, 0.4 kilogram is fine, okay? You just use one decimal place. Nothing wrong with that. All right. Janelle, your working was well done. Okay. Please let me know if you all understand this. I'll just run it through again. Volume of the box is equal to the external volume minus the internal volume. Okay, the external volume we found it to be 9,000 cm cubed. The internal volume we found it to be 6,196.5 cm cubed. When we subtract it, we get 2,803.5 okay cm cubed. Now I need to convert this volume here to kilogram, and they gave me here that every cm cube has a mass of 10.5 grams. So I just multiply them. The units will cancel off. I know many of you are worried about how it really cancel. You know it will cancel. All right. So the 28, the cm cube will cancel the cm cube, and I'm using this conversion factor here. Please remember, 1000 grams is 1 kilogram. Grams with grams. All right. Just multiply it out on the right hand side here nicely and put the units and then work it out in your calculator from there. All right. So, last question for tonight. January 2016. Okay. So, you have questions like these involving maps and so on. Okay. And they brought one here in January 2016, question 4. All right. Part A. Yes, Nicholas, I was only able to plan 3 questions tonight. All right. This last set of past papers that I did is a bit impromptu. It wasn't something really that I had a long-term plan with. Usually if I have a long-term plan in place, there will be preparation long ahead for it. Okay? The past paper workshop that took place in the Easter, that had a lot of preparation long before it. So I kind of winging it as it go in a sense, in the sense for the preparation of the slides and so on. So that's why it's like this sometimes. Remember, I have a job to fulfill too, okay? All right, so January 2016, paper 2, question 4, part A. The diagram below shows a map of an island drawn on a grid of 1 centimeters squared. Okay? Part 1. State in centimeters the length LM as shown in the diagram. So we just go into the diagram here. I want you all to count the number, the length here. Okay, scene 8 there. All right, 8 is correct. 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters. Okay, very simple, easy marks. All right, that's why I'm telling you all, don't leave out no questions. Work through them, see what you could pick off easily. Part 2. Estimate by counting squares the area of the map as shown in the diagram for 1 mark. All right, so when they tell you here estimate, estimate means that it's not going to be the exact value of the area, but it's an approximation. So you are using an approximation method. So what I would recommend is that for every whole square or whole block, we count it as 1 cm squared, and for every partial block, all right, we count it as a half a square. Simply because what happened is that some will be bigger, some will be smaller, and they will even out each other. Okay? They'll even out each other. 7.5. All right, so let me start with this thing. All right, let's start with the whole ones first. All right. Well, that's not a whole there, but 1, 2, 3, 4, 5. I'll count this one. Oh, 6, 7, 8, 9, 10, 11. I'll count this. 12. Now you could do this in exam, eh? Like, see how I'm writing on this? That way you're not counting and making mistakes. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yes, boy Biscuit. You had to count. All right. 26, 27, 28, 29, 30, 31, 32. All right, I'll count this one. 33. Okay? Now, like I said, they will even out, okay? And all I'm gonna go around here in a circle as such. This is negligible. I ain't gonna bother with that. 1, 2, 3, 4, 5, 6, 7, 8. I'll count this 9. I ain't gonna bother with that. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so this is 20 by a half here. Let me just do the calculation here. 20 by a half is 10, and we counted here 32 squares. So this is 32 plus 10. This is 42 squares, so 42 cm squared. Okay? So that's how I would recommend that you tackle this and do it. Is that clear, everybody? All right. Is that good, everybody? Oh, I had 33. Oh, I forgot this one down here at all. All right, so this I only watching this 32 here and not realizing I had 33. So all right, good. 33, so this will be 43. Okay, lovely. Like I said, everybody will get different values, but they should be approximately around the same vicinity, okay? All right. So this will be here 43 cm squared. Good night, Lovey. Good night, Aaron. All right. So part 3, on the island, the distance LM is 20 kilometers. Complete the following statement. On the map, 1 centimeters represent how many kilometers? Okay, so the actual distance here, when we go to part A here, LM we measured to be 8 centimeters. So in order to find 1 centimeter, what I'm going to do, I'm just going to take the 20 kilometers, this 20 here. All right, so 20 kilometers divided here by the 8 centimeters. So you're going to get here, this is messy. This is really messy. Sorry, yeah? 1 centimeter represents, I'll say it 20 kilometers divided by 8 here, which should be 2.5 kilometers. Okay, that's better. Exactly, everybody. I just took the 20 kilometers. We know that LM, which we found here in 4A part 1. All right, we know that LM is 8 centimeters, and you could see LM, the distance from L to M here. That is, we use that 8 here, divided, 20 divided by 8, and I'm getting 2.5 kilometers. So therefore, 1 centimeter represents 2.5 kilometers. All right. Part 4. Write the scale of the map in the form 1 to x. Now, you all would remember this, right? I told you all that 1 kilometer, 1 kilometer represents how many centimeters? Well, 1 kilometer is equal to 100,000 centimeters. And I told you all, learn that. Okay? Learn that well. All right? So, this 2.5 kilometers here is equal to 2.5 multiplied by 100,000 centimeters, which is equal to 250,000 centimeters. Okay? So, using for the scale here now, they want it in this form, 1 to x. So therefore, 1 centimeters, x here will be 250,000. That's the answer. All right, I'll go it over again. 1 kilometer is equal to 100,000 centimeters. Okay? 2.5 kilometers, therefore will be 2.5 multiplied by 100,000 centimeters, which is equal to 250,000 centimeters. So therefore, to write the scale here, in the form 1 to x, meaning 1 centimeter on the map represents 250,000 centimeters in real life. So that's all you need to write. All right. Part 5. What distance on the island will be 3 centimeters on the map? Okay. So we know that here we have a scale here. 1 centimeter on the map represents 250,000 centimeters. So I'll start with that here. We have a scale. This is my scale here. Let me not write down in the corner here because I'm not sure if that far displays on the screen. All right, so the scale here. One to 250,000. Okay. So 3 centimeters, and I could do it using my way too. I know here that 1 centimeter represents 250,000 centimeters, and they want to know what distance on the island. So I'm going to convert this 250,000 centimeters to kilometers. I know here that 100,000 centimeters is 1 kilometer. This is just the conversion factor to convert. When you multiply 3 by 250,000, you will get 750,000. 750,000 you have to divide it by 100,000 to basically get it in kilometers. So centimeters will cancel with centimeters. Centimeters with centimeters, so you're remaining with kilometers. 3 multiplied by 250,000 divided by 100,000, and this is in kilometers. So your answer here is 7.5 kilometers. How many of you all got that? All right. There are some shorter ways to work this as well. You could do some mental math as well and do this shorter. Because remember, this was just for 1 mark. Okay? That's good. I'm glad you all getting it. Lovely. All right. Part 6. What area on the island will be represented by 3 centimeters squared on the map? Okay? So we need to remember that 1 centimeter what area on the island will be represented by 3 centimeters? All right, now we know here that 1 centimeters represents on the map 1 centimeter on the map represents 250,000 centimeters in real life, which is the same as 2.5 kilometers. So therefore, 1 centimeter squared will be equal to represents 2.5 squared kilometers squared. So when I square this 2.5 here, okay, that's what I'm gonna get. Remember this 1 squared. 1 centimeter squared is 1 by 1. 1 squared is 1. Okay, so I have to square this. Remember, let me draw this so that I want you all to visualize this, right? Oh, Jesus. I think I need to get a shape here. All right. All right, so this here, this is 2.5 kilometers here. I don't know. I don't know. Remember, these are some older questions, huh? 2.5. Okay, so 2.5 by 2.5 here. Okay, so this will be 1 cm squared is equal to, when you multiply this out, you're getting what? 6.25? Okay, now remember here, they want you here to find out 3 centimeters squared. All right, so therefore 3 centimeters squared is equal to 3 multiplied by 6.25. So this is going to be 18.75 kilometers squared. All right, so let's go it over again. Make sure that everybody understand this properly. So they ask what area on the island will be represented by 3 centimeters squared on the map. Okay, now we know that 1 centimeters represent 250,000 in the scale here, centimeters. And this is the same as 2.5 kilometers because we know that 1 kilometer is 100,000 centimeters. So what that means, I draw a square here. So this side is 2.5 and this side is 2.5. We know that area of a square is side by side. So 2.5 by 2.5, this will be 6.25. Let's get another color. 6.25 kilometers squared. Okay, when I multiply them. So I have this and I could easily work. Okay, so if 1 centimeter is 6.25 kilometers, 1 cm squared is equal to 6.25 kilometers squared. 3 cm squared will be 3 multiplied by 6.25 kilometers squared will give me 8.75 kilometers squared. Please indicate it in the chat if you understand that. All right, part B. All right. The diagram below, not drawn to scale, shows a prism with cross-section PQRST and length 20 centimeters. PQRST is made up of a rectangle PQRT and a semicircle RST such that PQ is equal to 6 centimeters and QR is equal to 5 centimeters. Use pi to be 3.14. Okay, so let's see what this. We have two little parts here to do, and that's it. All right, so calculate the area of the cross section PQRST. So the area that they want us to find here is this section here. Okay, notice that RST, they told us here, is a semicircle, and PQ is 6, and TP here, or QR, is 5 centimeters. This is a rectangle, excuse me. All right. Okay. All right, so all I need to do is to find the area of the rectangle and add it to the area of the semicircle. So area of PQRST is equal to area of, this will be PQRT plus area of RST. So this is equal to the area of PQRT, which would be 6 multiplied by 5 plus, now the area of RST, this will be here. The area of a circle is pi r squared. All right, and because we find in a semicircle, we'll just divide by 2. Okay, 6 by 5 is 30. 30 plus pi here is 3.14. Now let's establish what r is here. Okay, notice here that PQ is 6 centimeters. So which means that TR will be 6 centimeters as well. And TR is the diameter of the circle. So therefore, the radius will be TR divided by 2. The radius here will be 6 divided by 2, which is 3 centimeters. So I now know my radius. So I could plug this in here. Pi is 3.14 multiplied by 3 squared all over 2. Okay? So you could work this out on your calculator very easily. And you will get here 30 plus 14.13. Adding this up, you're going to get here 44.13 centimeters squared. Are you clear with that? Please indicate in the chat if you are clear with that. Okay? To find the area, you lost from the formula? No problem. Listen, I have no problem going back over. You always just tell me if you're a little lost. Alright? Just don't sit down and watch me like turtle. Okay? Tell me. Alright, so this is the area here that they want us to find. PQRST. Notice that PQRT, this here is a rectangle. Okay? This is a rectangle. Alright, Nicholas, I'll break it down. I'll break it down for you, okay? It's no problem. I enjoy explaining myself, so it's not a problem explaining for you all. That's one thing I actually enjoy. Once you're actually applying yourself. So that's good. All right, so the area here, if I want to find the area of this rectangle, wouldn't it be not 5 by 6, 5 multiplied by 6, which is 30? Okay, this is 30 cm squared. And an area here of a circle. I have here the radius here. If this side here is 6 centimeters, it means that this side here is 6 centimeters. And this here is a diameter. So the diameter TR of the semicircle is 6 centimeters. So, but the radius is half of the diameter. So I'll say TR divided by 2, which is 6 divided by 2, which is 3. So the radius is 3 centimeters. Are you all clear with that so far? Now, area of a circle is given by pi r squared. So pi here is 3.14. All right, and the radius here is 3 squared. So area here is equal to 3.14 multiplied by 9. Okay? Yes, it's a semicircle. That's why I divide. 3.14. I just work it a different way so that hopefully this will be easier. Okay? So this here area here is equal to 28.26. Now, area of the semicircle will be, that'll be too jumbled there. .26 divided by 2. So this is how I'm getting here, 14.13. So what I will do here, I will take this 30. So area of PQRST, 30 plus 14.13. And I'm getting here 44.13. Okay? Please tell me if you understand that. I'll just go it over again. I just work it different ways for you, okay? This way it's simpler. It's just I wrote the working not in a very organized way. So I found the area of the rectangle here. 5 by 6 is 30. And now I need to find the area of the semicircle. So I have TR here, which I got the same length PQ. This is 6 centimeters. All right. But I want to find the radius. This is the diameter of the circles. Radius here is 6 divided by 2 is 3. So I know the radius here is 3. The area is given by pi r squared. That's the area of a circle. All right. The area here is 3.14 multiplied by 3 squared, which is 9. When you multiply 3.14 by 9, you are getting here 28.26. All right. Now to find the area of a semicircle, I just divide by 2. So this is 28.26 divided by 2. I'm going to get 14.13. Go around here. All right. So you're seeing it now. All right. And I'm going to say now area of PQRST. All right. I'll take this 30 and add it to this 14.13. And I'm getting here 44.13 centimeters squared. I'm glad so many of you understand now. All right. Okay. One more to go. All right. So part 2 here. An engineer needs a similar prism whose volume is not more than 900 cm cube. Estimate in centimeters the length of the longest prism he can use. Multiple choice. Janelle, you're not allowed to take multiple choice exams out of the examination. So I will not be doing any papers that are illegal on YouTube. Okay? If anybody wants to do that, it will not be me. All right? All right. So part 2. And oh, I read the question already. So we know that the cross-section volume here, just now, the volume here is equal to 9,000 or 900 cm cube. Okay, so volume here is equal to 900 cm cube, and they want to find the longest length used that could be used. So what we want to find here is L. That's what we want to find. Okay, now what I'm going to use here, I'm going to say here volume is equal to cross-sectional area multiplied by length. This is a formula that you need to know. Multiplied by length. Okay? So I'm going to say here, let length be x. Okay? So the length here, they want here to find the length of the the length of the longest prism he can use that will not have a volume more than 900 cm cube. So seeing that the volume cannot exceed here 900 cm cube. I'm underlining not. I need to write here an inequality that the volume here is less than or equal to 900 cm cube. So I'm going to write that here. So I could say here, the volume here, I just switching around this volume formula here, right? So area is equal to area by L is equal to V. All right. And I'm going to use how this set up here. So the area here, we know that the cross-sectional area, which is in the shape here, not this one, B. This cross-sectional area, PQRST, this area I'm talking about here, this area is 44.13. And the length here is X. All right. And it must be less than or equal to 900 cm cube. So we're just solving here for X. Okay. Now when we have a positive coefficient of X here, we can divide both sides of the inequality. So I could divide here by 44.13, divide by 44.13. Okay. So this cancels here. X here is less than or equal to 900 divided by 44.13 is so much. Okay, 20.39. That's correct. This is 20.39 centimeters. All right, so let me just put some meaning to this and then I'll explain it again, all right? Okay. All right, so an engineer needs a similar prism whose volume is not more than 900 cm cube. Estimating the length of the longest prism he can use. Okay? So the volume here is 900 cm cube. The length is L, but I just said here, let the length be X. Okay? I could have used L, didn't make much of a difference. Okay? So I know this formula here, volume is equal to cross-sectional area by length. This is a formula you need to learn. Okay, please commit this to memory. It will be useful. Okay, now I just switch around the formula here. Area multiplied by length is equal to volume. Now the area, I didn't write down the area, but the area that I indicated it here. The area that we're talking about is this area, 44.13, which is the cross-sectional area here. Okay? When we add it up, we got 44.13. So this 44.13 multiplied by the length here, X. So I'm just solving here for X, dividing both sides here by 44.13, and I'm getting here 20.39. So the prism should not be longer than 20.39 centimeters. Okay, so y'all, this is the end of the 3 papers. I am finished. It's 8:31. I'm sorry I didn't have more questions prepared for y'all tonight, but I'm happy that y'all were able to do 3 questions. Now, as I said, I'm kind of winding down things because I realize that y'all are really loaded with exams and so on now, and don't want to panic you all, but I'm deliberately doing these easier questions now. I did the vectors and matrices earlier in the week from Sunday night. I'm glad you all learned. Saturday night, I'm going to go through algebra. That is the number 2 questions. I'll make sure to have 4 questions prepared. Come out and let's practice. It's just good for practice. On Sunday night, I'll do 3 um, question 1 questions. And I'm doing it especially for the weaker students because you see how it closer to the exam. I just need to make sure that they have the confidence necessary to be able to at least do the easier questions. And who knows, with SPA marks and so on, they may be able to pull off a tray and get out of this math story. All right, maths isn't for everybody. I maybe like it, but I know a lot of people struggle with it. Okay. And Ramdani, why are you telling me enjoy your weekend? You're at school tomorrow. I'll see you in the morning, brother. You all take care. I am going to see you all on Saturday night for 7 p.m. Have a good evening.